Thank you. So as you said, my name is Jordan Birdsell. I'm the head of machine learning services at phData. We're a consulting firm, but I'm not going to be talking about phData, so if you want to know more about us, we have a booth over there after the talk. Feel free to come and chat. So as you mentioned, I'm going to be talking about MLOps, which is the assembly line of machine learning, if you will. And so some of you in here probably are wondering what MLOps is. Maybe it's new to you. Others, maybe it's not a new concept, but you haven't yet had success with it and are having some struggles getting models into production. And so yeah, so today we're gonna try and address those questions and get into what MLOps is. And the way I'm gonna approach this is I'm gonna start by effectively telling a story of what we see as the traditional data science approach. And I don't mean here to suggest that all data science approaches are the same, but this is just a common way that data science projects have gone down as far as we've seen it. And so I'm going to start out with that story, and then I'm going to point out some gaps in that traditional process, and then I'm going to jump right into how MLOps addresses some of those. And so again, what I want you guys to get out of this isn't going to be super technical. I know a lot of the presentations here are technical, but what I'd like you to get out of this is an understanding of what MLOps is, and specifically the capabilities it provides and the problems it solves. And so that's again why we're taking the kind of the storyline approach as opposed to pure technical things. So at phData, we have a number of customers, and almost all of them are Fortune 500 or big companies, and we can't talk about their stuff. So we made up a fictional company that I can tell this story with. And so we called them Nacho Now. And so just to set the stage for Nacho Now is the hottest new food truck in the Austin area and around the country. And they hired this guy, Dan Murphy, who's the chief nacho officer, if you will. He's a bit of a visionary, and he's wanting to solve some problems they're having in forecasting inventory, forecasting staffing, and even something he's calling micro forecasting, which this is actually based on a real use case, but it's effectively where you're going to look at weather and other local data to try and predict at any given point in time, how many baskets of nachos should I be cooking? So that way when the customer comes, the food's already prepared. And so to set out to solve this, he hired a bunch of data scientists, or a team of a few data scientists to solve that problem, and they get to work. So they start bringing in various data sources, ERP system data, promotions, weather, etc. They bring all that onto their laptop and get to work. And so, they're working in Jupyter notebooks, they're doing all their feature engineering, etc., to set out and solve this problem. And voila, they come up with some models. Now, I know I skipped a lot of the exciting part for most of you, but that is my intention. I'm not here to talk to you about how to build models. There's been plenty of presentations on that. We're here to talk about the other side of the story. And so they take this back to Dan, and Dan's super excited. They're all amped. They want to get these models into use. And so Dan asks the question, so how do we now integrate these into our business processes and into our stores? And so the team goes back and they start talking amongst themselves, and they say, all right, well, we're going to start with AWS. And we're going to deploy these solutions out to AWS. Now the question becomes, well, how do we do that? So data scientist, let's just call her Jill, decides to first focus on the inventory forecast model. So she starts with her model. Again, skipping over the details of that. The inventory forecast model is going to be deployed, let's say, as a REST API, so it can integrate with the existing forecasting system. And so, she first needs to set up some feature engineering, data ingestion, and all of that needs to be orchestrated. And so maybe that's an Airflow or something like that, running a Spark job and EMR or something. Next, she sets up her serving infrastructure. So let's say in a V1, this might just be a plain old EC2 instance running a Flask app with Gunicorn and Nginx for reverse proxy. And so data scientist 2 comes along and starts focusing on staffing model. And so they have some similar problems, right? They need to do data ingestion, feature engineering, workflow orchestration. That's pretty common in most solutions. But this one This one has a slightly different delivery method and integration with the end user. And so the way the staffing model is going to work is she's going to build a dashboard that basically the store operators will then use to inform their staffing decisions. And this data scientist also decides to implement some data quality, right? So if I get bad data and forecast this incorrectly, I'm going to have a bunch of people on staff that I don't need. So lastly, kind of the more challenging one is the micro forecasting model. And so third data scientist starts working on this one. Maybe they enlist some engineering help. Again, data ingestion, feature engineering, same process there. We layer back in serving infrastructure because the way we're going to integrate this solution with our customers is likely exposing an API, and then some existing software system within the restaurant is going to integrate with that and display, hey, cook 2 baskets of nachos right now. This one has a much more dire and immediate impact if it goes wrong on the customers and the businesses. And so we layer in a couple new things with this one that we didn't have in the inventory forecasting, and that's resource management and application monitoring. And so for resource management here, that might be, rather than just doing a single EC2 instance, maybe we're now going to use Kubernetes or ECS or something like that, and then we're going to have some parameters put around that for auto scaling and things like that. Application monitoring, again, it's a critical application, business critical application, and so if that goes down, we have a problem. And so setting up some logging, basic logging, heartbeats, things like that, that we're logging to CloudWatch and put some dashboards on with some alerts, pretty straightforward. So we have 3 different architectures effectively developed by 3 people. Now, I know these are just boxes with capability names, but let's assume for a moment that, maybe even the data ingestion approach was different for each one of those. And that's not terribly uncommon to happen. We get busy, we get focused on our work, and we lose track of kind of the collaborative nature. And so, anyways, we're feeling pretty good, right? We go back to Dan, we say, hey, we got our 3 models into production. Cool as a cucumber, right? Everything's going well. So what's the problem? Well, week 1 after deployment, IT security comes along and says, hey, anybody in the world can access this API. That's a problem, right? We could be exposed to DDoS. We could, any number of issues there could happen. In the same week, we've got a business governance team that comes to us and says, we really appreciate what you're doing, but at the same time, you have no way of telling me how you came up with this solution, right? Now, for nachos, that probably doesn't matter, but if you're running insurance or any kind of audited industry, that becomes a big problem if you can't demonstrate how you've come up with a model. And this is a huge gap in the industry at most companies. Next, a couple months go by, and the store operators start calling up Dan Murphy, our happy, chief nacho officer, and they're telling this story of, hey, I don't think this solution's working anymore because it's telling me to cook, 10 baskets of nachos on a day we're closed, right? And so what's happened is our data has changed. Maybe some of these stores changed their schedule, but we haven't updated our model, or we haven't accounted for something like that. And so we're experiencing concept drift here, and we weren't monitoring for that. And you did notice probably on the micro forecasting one, we had application monitoring, but we did not have model monitoring. So key difference there. Next, we already kind of hit on this, but there was no repeatable patterns, right? And so, 6 months down the road, we hire a couple more data scientists. They want to solve some new problems. Then they go to deploy, and they've got to reinvent the wheel. Or maybe they use some of the best practices you learned, but you're not really getting a lot of economies of scale there. And so that's a challenge. Next, there's no deployment automation or CI/CD. And so in the example of the store operators calling and complaining that the model is drifted, of course, they wouldn't use those words. But so you go back to the drawing board, you retrain, you refit, and you're ready to redeploy that new model. And unfortunately, there's no automation in place. So getting that retrained model into production, you have to go through a lot of manual steps again. And so that's an issue as well. And so let's jump in now to kind of what an MLOps approach might look like. And kind of in line with the title of the presentation, I always find it useful to think of it as the assembly line. And so in the automobile example, Henry Ford didn't invent the automobile, but he did innovate quite a bit on the assembly line, and that's what allowed Henry Ford to take the idea of an automobile and make it a real thing for the masses. And so I think MLOps, in my mind, is effectively that for machine learning. So machine learning and data science, these are all great things, but it's not really hit the masses yet, and I think a lot of it is because companies are getting stuck at that POC phase and getting past that. So let's start by building up kind of a coalesce, if you will, of our different architectures and see if we can't start layering some best practices in. So here's our inventory forecast model. Let's layer in the staffing forecast model. So they had data quality and dashboarding. And then micro forecasting had resource management and application monitoring. And then, as we talked about, there's security, there's governance, there's all these other things that we need to consider, so let's layer those in too. And again, I know these are boxes on a screen, so it probably doesn't mean a whole lot to you, but it's important that you first understand the capabilities. And so for governance, that's a pretty broad bucket, and I don't mean to suggest that what we're going to talk about is the only piece of governance that matters, but the more immediate one that I've seen at companies is the need for that lineage from training all the way to production. And so a lot of tools out of the box offer this, or I shouldn't say a lot, but there's a number of tools now that are offering this. SageMaker has this built in if you're using SageMaker. MLflow has a tracking capability that handles this. Anything that claims to have the experiment tracking, that's a big part of this. Now, some of those, they only focus on the experimentation side and not on the deployment side. And so, so that can be a gap. Security, there's actually a lot of different layers to this, and I'm not going to laundry list them, but we have all the way from our APIs that we're exposing to our data, our S3 buckets, if you will, and so forth. Are we running our models in batch under a process ID, or am I running them under my user ID? That's a common problem in the data science space. And then model monitoring, fairly straightforward. Most people today, what the solution for this looks like is just a traditional logging monitoring tool where you can, some kind of framework for logging, putting metrics into a database, and then visualizing it with Grafana or something like that. But we are starting to see some more prescriptive approaches to model monitoring show up in the marketplace. A couple that come to mind. SageMaker just announced that they're going to be doing something along those lines. In fact, I think that at least the first version of that is out. There's others like Superwise. That's a kind of a prescriptive approach to model monitoring where they suggest the metrics that you monitor. At any rate, and CI/CD, again, having something in place that you can script all of your automation, whether it's for deployment or continuous training. If you're wanting to retrain maybe these 5 experiments every night and track the metrics associated with those runs, and then maybe promote one to production once it starts performing better. And so what might this look like? Just to give you a few examples. Again, it's hard to really paint the picture here, but I am going to show you some tools that fit into this space. I did touch on a few there, but it's important as I show these to understand that, again, there's tools, and then there's what's the word I'm looking for? The kind of integration of all these different pieces, right? You can easily plop tools into your AWS environment, but getting them to work together is a challenging part. And so these are just some examples again for data ingestion. It's a very saturated market, so whatever you choose to use, there's a lot of good tools there. We have a Tunity up on the slide. The little brain here is just a SageMaker icon in AWS, but it covers a lot of different things. Feature engineering, governance, serving infrastructure, model monitoring, et cetera. You can see Jenkins down there for CI/CD, CloudWatch and QuickSight for monitoring and dashboarding, Airflow, and IAM, and so forth. And so again, just some tools that we've used to build our solution around at phData. But again, I can't overemphasize that it's not just the tools on the page, it's the integration of those tools with automation, process, and best practices. And so let's look at what we're in right here. So with the MLOps approach, we have repeatable paths and automation. So when a new data scientist comes on board, there's documentation in place that they can refer to that says, hey, build your solution like this, and you can deploy it with ease. Next, we have lineage and security. And so, any auditor can come in at any point in time and say, this is exactly how this model was produced. I have the source data that was used to train. I have the testing snapshot, et cetera. And that's all very well documented, and security as well. Model drift is detected early, concept drift, and it's corrected often automatically. Depending on the company or in the industry you're in, that may be okay, that may not be okay. A lot of financial services companies still need human intervention before you redeploy a new model, but you can certainly do that. And lastly, new model versions are deployed really with just the click of a button. And so that the automation of deployment and things like that has become a lot easier. And so I guess what I'm hoping, again, is that you've gotten a sense for the kinds of problems that MLOps solves and maybe some idea of the technologies involved. But certainly there's much deeper aspects to this. And again, we have a booth over there if you're interested. Would love to talk in more depth. Even have some case studies we could refer you to on as well. So, yeah.
Thank you, Jordan. Yeah. We just have one question for today. Oh, a couple more trickling in. So I want to probably deal with them afterwards. How does your team handle being consistent on model documentation to ensure compliance with security, governance, and privacy concerns? And at what point is the documentation sufficient?
Yeah. So for the first part of that question, the benefit of being a consulting firm is that we get to do the same thing over and over again at multiple different places. And so we have a lot of documentation templates that form what we call runbooks or handoff documents or things like that. And we address a number of different components. And usually we get to prescribe that, hey, this is how we're going to deliver a model to you. You'll get all the code and the artifacts, but you also get these documents. And so it's pretty easy for us to stamp that out. If you want specifics, we can dive into that. But what was the second part of that question? Yeah, these two-part question. Accountability. Which one are we looking at?
Right here.
What point is the documentation sufficient? So I'm not sure if this is related, but if the question is documentation more sufficient enough to not require tracking of lineage? And I think probably at many organizations that's the case. Especially if there's no external, like governmental auditing body there. But I used to work at State Farm, for example, before coming into consulting, and tracking lineage in a systematic way was a requirement.
Yeah. Thank you so much.
Yeah.
Thank you, Jordan.